Hi everyone, welcome back to the channel. This one is a tough problem and this is mainly for IIT JEE Advanced and also for somebody who is preparing for Olympiads. And if you are able to solve this problem on your own, then you got a very clear concept and you should be able to crack the IIT JEE Advanced or even Olympiad pretty easily. Okay, so let's see what's happening. There is a frictionless rod and that rod is making an angle alpha with the horizontal. Okay. And there is a ring of mass small m, and this ring is free to slide on this rod, which is frictionless. And there is another mass m which is attached to the ring through a string. Okay. And initially it is held in a vertical position, completely motionless. And when we release the ring, it will tend to slide on the rod. And when it slides on the rod, this will start also moving. So the question is, what is the instantaneous acceleration? The acceleration immediately when we release the ring. What is the acceleration of m in this position itself when this is still hanging vertically? Okay. So that's the question. If you want to give it a try, please go ahead and then come back and check out the answer. Okay. So as usual, let's start with the free body diagram here. Okay. So what exactly you think is going to happen? If you see, when you release this ring, then this ring will tend to go along this line. It will try to slide on the rod, which is frictionless. And also, because this is sliding, so it will try to move the mass m as well. Since it is hanging freely through the string, so there will be an angular acceleration in this direction. Okay. So I hope this is clear. So let's assume that this acceleration is a, and let's say this angular acceleration is beta. We are not taking alpha because this angle alpha is given here. Okay. So let's take beta as the angular acceleration for this string, and the acceleration for the ring is a. Okay. So with this, let's see first for the ring. Okay. So this is my ring. Okay. And this is going in this direction with acceleration a. There is a tension which is downwards, and let's call this tension T. Okay. And mg weight is also acting downwards. Now if you see this, okay, then this angle is alpha because this angle alpha, so this angle will also be alpha. Okay. Therefore, this is 90 minus alpha. Okay. So this is the free body diagram for the ring. Okay. So let's write the equation now. So let's say this is x-axis and this is y. Okay. Okay. So f in x direction, so fx equal to max. Okay. And that gives me t sine alpha plus mg sine alpha should be equal to ma. Okay. Let's call this equation 1. Okay. Now let's draw the free body diagram for mass also, the bigger mass. Let's say this is m. Tension T is pulling it in the vertical direction. Okay. And mass mg is downwards. Okay. And if you see, this has an acceleration a here in this direction, because since ring has the acceleration a in negative x direction, then the whole system has an acceleration. Okay. And then because this string is moving with angular acceleration beta, so there will be one acceleration here in this direction, which is beta L. Okay. You got it? Because it is rotating like this, so it will have acceleration perpendicular to this line. Okay. And again, this angle is alpha. Okay. I think you get it. And here also same axis, we can choose the same axis, which is x and y. Okay, and then if you project this, then this angle is also alpha. Okay, so now we can write the equation for bigger mass m. Let's write the equation in the x direction, and hence this time it will be bigger m and acceleration the bigger m in x direction. Okay, and this gives me mg sine alpha minus t sine alpha equal to ma plus m beta L cos alpha. Okay, so the projection of beta L in this direction is beta L cos alpha, and A is already here. Okay, so let's call this as equation 2. Okay, and let's also write the equation in y direction. Okay, so MAY, and that is nothing but T cos alpha minus mg cos alpha equal to m beta L sin alpha. Okay, so T is acting in this direction, so this is alpha. Okay, so T cos alpha, this is also alpha. Okay, so T cos alpha minus mg cos alpha equal to m beta L in this direction, which is 90 minus alpha, so sin alpha. This is my equation number 3. Okay, so far so good. So now we just need to solve these equations. Okay, so let's start doing it. So if we take from 1 and 2, so what we get is mg sine alpha. We'll try to replace t here from here. Okay, so minus ma plus mg sine alpha, because t sine alpha is here, and we can just replace the entire t sine alpha, and that is equal to ma plus m beta L cos alpha. Okay, therefore that gives me m plus m g sine alpha equal to m plus m a plus m beta L cos alpha. Let's call this equation 4. Okay, and now let's also solve the equation 1 and 3. Okay, so we'll do the same thing. In 3 also we have t, so we'll replace t from here, and therefore what we'll get is, instead of t we can simply write ma minus mg sine alpha divided by sine alpha. So this we get from here if you take mg sine alpha this side, and then we also have cos alpha here, so we should write cos alpha minus mg cos alpha equal to m beta L sin alpha, and therefore if you expand it, it will become ma cos alpha minus mg sin alpha cos alpha minus mg sin alpha cos alpha, and that should be equal to m beta L sin square alpha. Okay, and then if we just collect few things here, so ma cos alpha minus m plus m g sin alpha cos alpha, and that is equal to m beta L sin square alpha. Let's call this equation 5. Now we have almost completed solving this equation. We can deal with now this 4 and 5. So what we need to compute? We need to compute A. Okay, so hence we'll try to equate for the beta L, and then we try to solve for A. Okay, so from 4 and 5 we have this m plus m g sine alpha. Okay, and that should be equal to m plus m A, because we want to keep A, and replace the expression for beta L from 5. Okay, so what is m beta L from here? We see that this is m A cos alpha minus m plus m g sine alpha cos alpha divided by sine square alpha. So that is equal to m beta L, and then we also have cos alpha here. So we will write cos alpha here. Okay, now simply expand it. Take sine square alpha here on the left hand side, so it will become m plus m g sine square alpha and sine cube alpha, in fact, because there is sine square already, and that should be equal to m plus m a sine square alpha plus ma cos square alpha minus m plus m g sine alpha cos square alpha. Okay, now just do some arrangement here. Okay, so what we can do is we can take m plus m g sine alpha as common, and therefore we will have sine square alpha and plus cos square alpha if we take this part on the left hand side. Okay, and then this is equal to, if we take A as common, m sine square alpha plus m sine square alpha plus m cos square alpha, right? And if you see this is nothing but m and this is nothing but 1, so we get m plus m g sine alpha equal to a m plus m sine square alpha, and therefore we get a nice equation for A, which is m plus m g sine alpha divided by m plus m sine square alpha. Okay, so this is a nice expression for A. Okay, now let's look at the bigger mass m. Okay, because we need to figure out the total acceleration. So the bigger mass m here, it has A in this direction, and this direction we have beta L. Okay, so the total acceleration will be vector sum of these two. So let's say if total acceleration of m is vector sum of A plus beta L, right? So we need to compute beta L also. Okay, so we'll take the from equation 4. If we take the equation 4 here, okay, from this one, okay, we can pick 5 also, it doesn't matter. Okay, but if we take that one, then we already got m beta L cos alpha equal to m plus m g sine alpha minus, instead of A we can just replace with this one, m plus m g sine alpha divided by m plus m sine square alpha. Okay, so if you solve this one further, we get m plus m g sine alpha also we can take as common, and then 1 minus m plus n by m plus m sine square alpha, and that is equal to m plus m g sine alpha, and m will cancel out, and then we'll have m sine square alpha minus m, so which will be minus m cos square alpha divided by m plus m sine square alpha. Okay. Therefore, we get beta L as, because if you see this m will cancel out, so we'll eventually get minus m plus m g sine alpha cos alpha divided by m plus m sine square alpha. Okay, so that's the expression for the beta L. Okay, the acceleration due to the angular rotation. Okay, now if you see these two equations, this and this, they are pretty similar, and therefore we can write beta L also as minus a cos alpha, right? You can see that. Therefore, what is the angle between these two? So alpha, so AM is a square plus beta L square plus 2a beta L cos alpha, right? So we need to compute this, and therefore we can have AM as a square plus, instead of beta L we can write this, so a square cos square alpha plus 2a minus a cos alpha and cos alpha, because angle between these two is also cos alpha. Okay, and therefore this whole thing is nothing but a square minus a square cos square alpha, and AM is a sine alpha. Okay, therefore the actual acceleration for mass m is a sine alpha. And what is a? So a is m plus m g sine alpha. So m plus m g sine square alpha divided by m plus m sine square alpha. This is the final expression for the acceleration of mass m. You should try and compute the tension and the velocity of ring or the acceleration of ring also at any point t. It is not easy to solve this problem when we assume that the ball has already, or the mass m has already moved through an angle theta, and m has moved to a distance, let's say delta L, because then we will need to consider their velocities also. You need to note here that we are taking velocity as 0. Otherwise, the force in this direction for the bob, for the mass, will also have a centrifugal force, centripetal force. We are not considering this in this direction because the velocity is 0 at any instantaneous moment. Okay, but after some time it will be there, and this problem will become even tougher. I hope you like this problem. Please do subscribe and share this with your friends or anybody you want to, and also please do like the video. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.